and welcome to Velodyne Lidar's virtual CES 2022 experience. I am Jane Maynard, Velodyne Lidar's Senior Manager of Communications. With our company's commitment to safety paramount, Velodyne made the decision to not participate in person at CES 2022 due to the surge of COVID-19 infection rates. We want to thank everyone for their flexibility and extend our well wishes of health and safety to all in the new year. In lieu of our in-person booth experience, we are providing our partners' presentations in a virtual format here on Velodyne Lidar's YouTube channel. I am happy to introduce you to Emesent, a leader in LiDAR-based drone autonomy and mapping, with a focus on underground mining and industrial asset inspection. Emesent's Hovermap product is a versatile and intelligent LiDAR scanner that makes mapping of inaccessible areas safe, easy, and fast. The Hovermap can be integrated with Boston Dynamics Spot Robot, which we had planned to demonstrate at our CES 2022 booth, which obviously we cannot, but you are still going to see this fun combination virtually in the presentation today. All right, Dr. Jeremy Sifonia, technical evangelist for Emesent, is now going to present to us. He will discuss their technology, how they use our LiDAR, and more. Off to you, Jeremy.
Well, thank you very much. And thank you to Velodyne for the opportunity to join you for this virtual CES activity today. I'm going to tell everybody a little bit more about Hovermap, our mapping and autonomy capabilities. And I thought to get started, I'd go through some of what I would consider key considerations when selecting new equipment. And, there at CES, there's so many amazing products and so many amazing pieces of kit. I think that this is a really fundamental way of looking at how we select our equipment. We all want that high quality and we want the low cost, but that's actually an elusive target. It's very hard to have both. We also want it done quickly, so we want to get that job done, but oftentimes quickly means low quality, right? So there's always this balance of quality, cost, and speed. Quality is an important part of what we do, but also accessibility. So the ability to use our product or other people's products in different spaces and access different aspects of a project site. Efficiency is critical. Time is money, and we want to make sure that we move on with and collect the data or that we're after efficiently in a time-sensitive manner. And safety, of course, is always paramount. So where does Hovermap fit onto this? I reckon it's pretty well centered right in the middle of the triangle. We've done a really good job of having a very rapid-based scanner. It's a SLAM-based system that we'll go over in a few minutes. It's relatively low cost for what it is, and especially for the high-quality deliverables that we're able to produce. We are able to access different areas that were previously inaccessible and do so safely and efficiency. I believe that this is most fundamentally based on our uniquely versatile system. It is a market leader, if not unique in the market, in its ability to be adaptable to drone-based platforms, walking vehicles. We can lower it down cables, and this is pretty much what I'm going to focus on in the talk today. I wanted to really highlight this uniquely versatile capability of Hovermap. So this is Hovermap, and of course, the main component on the front end there is from our partners here at Velodyne. Hovermap is quite lightweight, 1.8 kilos or 4 pounds. It's constructed of high-strength carbon fiber body with an aluminum alloy frame. Inside is a powerful Intel NUC CPU. With this quality, this allows us to develop really robust SLAM LiDAR mapping capabilities that facilitate safe GPS-denied flight through collision avoidance and advanced autonomy capabilities. Accessibility was the next thing on my list. Oftentimes, we're working in places with no GPS. No communications, no maps, and they're inaccessible or at least not safe to enter with humans. Hovermap reaches these gaps. Efficiency, we have a very simplified workflow. You fly, walk, basically capture your data, connect to Hovermap to download the data directly to a USB. This happens automatically. Insert it into a computer, process the data, and our processing times are some of the fastest in the market. 1 to 2 times the scan time. So if you're scanning for 10 minutes, you can expect 15 to 20 minutes to process that data and have your high resolution data available in a number of different file formats ready to be consumed in one of a number of our partner software packages. safety, this is a really important issue. And for those of you that may be familiar with the hierarchy of controls, the most effective is to eliminate the risk. PPE is the least effective. You're just covering your stuff. Replacing humans with robotic systems is a form of elimination. This is the most effective level on the hierarchy of control. One of the really cool tools that Emesent has developed over the last couple of years is this SLAM-based merging. So no more manual merging of multiple data sets. This all happens within the Emesent software, and it creates a single unified, seamless combination of multiple data sets. Here you can see an example of a large statue in Indonesia, where there were 4 flights and a walking scan, that's the orange one down towards the bottom, brought seamlessly into a single model. This is really important because, as I mentioned earlier, Hovermap is platform agnostic. It doesn't really have a preference as to how it's being used. If it's on a flight, if you're using it in a car, if you're walking with it. And we can capture data across an entire scene or landscape and bring that all back together with the merging tool. I wanted to throw this one in because I think it's really cool. This is a mine site in Canada that we visited a couple years back, but I love it. Here you can see we're walking with the scanner in the left-hand corner, bottom left-hand corner. He asked me to fly into this hole, and I said, no, it's not going to fit. So we just duct taped it to a pole and shoved the scanner into the hole. And of course, we flew around the interior of the workshop and crushing facility as well. This is an example, or this is the resultant point cloud that we obtained from those multiple scans. We also did a flight outside. See, through this cut-through view, there are areas that we would not be able to attain if we just flew. There would be areas that we would not be able to see if we just walked. Through the ability, rather, of being able to combine and merge these into a seamless scan, we now get a more complete picture of that existing environment and targeting our areas of interest. And just before we finish off, again, I used some duct tape and a pole, and I put Hovermap into this hole. This is an old entrance to a mine. It was flooded with water, and we were able to just reach down inside and see where the water level was at. And that's really what the main interest was in that situation. But all brought together using the merging tool. So the versatility of the system is really the highlight of this discussion. And as you can see here, we can use Boston Dynamics Spot. There's a cage on the right-hand side that's really excellent for lowering it down vertical shafts. The backpack system is excellent for walking. It's on a vehicle mount there on the middle, and of course the drone applications, which is what most people are most familiar with. But this kind of versatility is really important because it actually helps with your return on investment. It's not just an expensive tool for one job. It's a tool that you can use across multiple jobs in multiple scenarios in different ways to get that return on investment faster. It's also excellent because it has minimal training required. We can teach someone from very little experience to being flying underground by themselves within a day or two. Rapid deployment. You can move from site to site very quickly and easy because of its easy use and simple workflows, and setup time is very short. Usually I tell people that if we're not up in the air or started work in 5 minutes, it's because we're talking too much. So we can combine the multiple scans, which is all part of this versatility, and that helps us develop the quality deliverables that we're after. This is an older video some of you may have seen in the past, but it cracks me up every time I see it. This is from our friends UAS Inc. in Canada, and this is about as creative as it gets, I think, as far as trying to get our Hovermap system into inaccessible places. Evidently, this wasn't capable of getting there with the drone. The pole wasn't going to be sufficient, so they strapped it right to the bucket of this loader. And by the way, this is a teleremote loader, which means that it's being remotely operated. The driver is not in the vehicle. He's safe back in a safe area as well. So just goes to show how adaptable and creative we can be when we start using the Hovermap system. This is the point cloud that we obtained from that dozer. So this means that we can use it not just in different ways and on different platforms, but in different industries. Mining has been our core focus for the first few years, but now we're really making new headroads into the oil and gas and AEC or architecture engineering and construction spaces, urban planning, underground transport, industrial infrastructure, telco towers, bridge inspection, and some of the exciting work that some of the new work that I'm excited about is in the emergency response space. From this, we can build and construct as-builts for QA/QC, the buzzword digital twin, of course. This can provide situational awareness, especially for an emergency response situation, asset inspection, condition monitoring, rehab and maintenance, deflection and geometric alignment are really interesting use cases, and they can also be associated with change detection, design, planning, and basically facilitating digital management. So across multiple industries, we can now digitize these spaces rapidly and accurately so that we can now manage those spaces in a digital format. So the drone is kind of the show pony. This is the DJI M210 where we started with Hovermap. Then late last year or mid last 2020, we went on to the DJI M300. And more recently, bear with me just for the volume here, we've gone on to the Zoe platform. So some really exciting things that are going to be happening with the Zoe, and as it opens up new opportunities in different markets. With our drone applications, we have different levels of autonomy, and this is a basic view from the level 1 autonomy or Hovermap mapping autonomy. And on the right-hand side, we can see our collision avoidance capabilities, as well as just your normal DJI controls with real-time video back to the operator. More recently, we've been deploying the real-time point cloud capability with the tap to fly system. This really is opening up the doors for beyond visual line of sight in GPS denied environments. It's also very helpful to have that so that you have that real-time point cloud coming back and understanding where you are, where you've been, where you have collected data, and if you've missed anything along the way. All this, of course, works with our advanced fail-safe. So if you're going to let the system go, you need to have faith that it's going to come back. So we have a battery return to home fail-safe. We have dust fail-safes. We have loss of communication fail-safes. So the system is really allowed to go out on its own and operate safely and return home with confidence. Of course, we want to show you some of that. So here's an autonomous beyond line of sight. You can see the first part that it's just got to navigate past that mesh. So this is now all beyond line of sight. It's all beyond it's not within the control of the operator. At this point, it just found its way underneath this kind of bit of water falling from the back. So this is in an underground mine. It's decided that it's safe to carry on. You can see how it's kind of dodging even the small obstacles as it's gone through. It's mapping as it's moving through, and it's now hit a big cloud of dust, which is kicked up through its own propellers, and it has to make a decision of whether or not it's safe to keep going or if it needs to return to home. So this is an example of the dust fail-safe. And ultimately, I think, well, you can see here, it's decided that it's safer to return home, and it's completely caked with now dust or mud from the water, then the dust. It's gone back over the brow and returned all of that fully autonomously using Hovermap autonomy capabilities. And I love this shot because that was a brand new Hovermap and a brand new drone, and it got completely annihilated. So, but here's some of the results from that flight. So mission achieved, data collected, return to home safe, all within beyond the line of sight and capabilities of human being able to enter into that space. And of course, there wouldn't be a technology demonstration without seeing Boston Dynamics Spot robot, which is just incredible. Here, our friends at ARM-US in Utah have deployed a Hovermap within the underground mining space. And what I like about this is it shows how rugged the systems really are. I mean, they have to be able to not only survive, but work in and collect quality data within these types of working spaces. So the guys at ARM-US have definitely done some rigorous testing, and I think that it's really proven to be a really nice combination with the Spot vehicle and Hovermap as a combination. There's more on that combination coming up a bit later in the chat. So I thought I'd run through a few data set examples so that you can see the quality of the data that we're able to produce using the Velodyne VLP-16 Puck Lite. So bridge inspection is a popular choice, but I also think that some of these LNG, these link terminals, et cetera, in the oil and gas field are pretty amazing. Of particular interest is the jetty on the left-hand side, but they also flew the insides of these containers. The reason for this was a reverse engineering project. The containers had reached their end of life. Back when they were built, they would have been on paper blueprints, and the thought of going through hundreds, if not thousands, of paper blueprints to reverse engineer this was a bit daunting. So our colleagues at Halo in Indonesia, they flew inside of this space, and then they could use that digital model to reverse engineer those tanks much more efficiently. One of my other favorite applications for Hovermap, again, this is kind of off-drone use. This is by lowering it down a ventilation shaft. This is in a mining space, but it's a 5-meter diameter shaft that's 500 meters in depth. And here you can see that we've got Hovermap in its cage, put a bit of plastic on the top just to prevent a bit of water from coming down. There was a lot of water falling into that vent shaft. It's used there. They're using quite a large crane, which kind of made me laugh when we first saw it. A bit overkill, I thought, but it actually has to do with the amount of cable that they need, not the load-bearing part. The video on the bottom is actually a live view of the camera system showing Hovermap as it's being lowered into the system. And then you can see on the right-hand side, the nearly 570 meter long ventilation shaft. But we're not just creating pretty pictures. These are giving new insights and making management decisions. So in this instance, they were having a problem with the self-mining. So there were rocks that were kind of falling in on themselves, and they wanted to see what they could do to correct it. So we scanned it once, and then we came back 12 months later, and we can actually use some change detection algorithms using Maptek's Point Studio software, which here, in this case, the gold colors represent rocks that have already fallen, so prior rock fall. So that's a change from the last year. And these hot colors are potential future rock falls. So with this sort of information, the engineers can now look at the data and try to figure out or how best to manage that environment moving forward. In the buildings and AEC space, this is a great one from Hark and Aerial and our friends at Quantify over in New York. For those who may not already recognize it, this is Grand Central Station, or Grand Terminal Station in New York City. And I just thought that the quality and the clarity of the data was just stunning. Some of the finer details on the railings and the fence sort of been collected in a walking scan, and being able to just walk around this environment. One of the first things I noticed is how few people there were, but I think that may be one of the small benefits of COVID is that basically there was nobody there. So it made for a much cleaner scan, and they could take their time, but I think this whole scan was collected in just maybe 10 minutes of walking around. But in the AEC space, there's a lot more that we can do than just walk around. This is an example of it's a multi-story hotel in the middle of Brisbane's CBD. Let me just put myself on mute. So I might just pause it there and cover a couple of things. So first of all, I think the data set just looks amazing. But there was about 3 or 4 of us there on the day. This was a combination of flying scans as well as quite a few walking scans. So we walked every single floor and all the stairwells and all the car parks down underground. And we merged that all back together with our merging tools. Hovermap in this case not only provided the point cloud that we see in this image, but also the collision avoidance capability in that GPS denied environment, or what they would call urban canyon environment between the buildings. So collision avoidance, obviously in that kind of space is really critical from a safety perspective. Of course, from a human perspective, but also in terms of equipment and keeping everything safe. We were also carrying a ZenMuse camera during the shoot, and we were able to do facade inspections. That was actually part of the task of the job. So multiple things going on in one simple example as far as the data. Here's another couple of examples that I like to share. The one on the top left is actually an elevator shaft scan. And I don't know if anybody on the who's viewing has ever tried to do an elevator shaft scan with like a terrestrial scanner, but it's kind of tedious. You have to open up every floor, every door, and work your way up a building one level at a time, kind of peering into the shaft and scanning as best you can. There's also a safety element associated with that type of approach because you literally have an open shaft. So there are safety considerations. In this case, we simply opened up the hatch on the top of the elevator inside the cabin, used Hovermap's magnetic mounts and attached it to the top, pressed all the buttons and let the elevator ride itself up and down. And that's the point cloud that we obtained. Inside on the right top hand right corner is a power generation facility at a hydro generation plant. It was in operation at the time, so they didn't want me to walk around the assets. So we did an indoor flight and I was able to capture that data. Bottom left is what they call a buffer. It's a huge indoor stockpile, and it's a really important part of the life or the operational aspect of a mine. If the underground component is mining more than the production is, they can store that excess mining here. And conversely, if they're slower down underground, then they can utilize the reserve in the buffer. And so understanding this kind of volume is a really important part of the daily operations of the mine. And previously, they didn't have a really good way of calculating its actual volume. The bottom right-hand side, lower, is it's a train tunnel in Germany. And our CEO was just walking down the street, and he collected that data as fast as he could walk through that environment. I think it's beautiful. Here's another example from the hydroelectric facilities. Basically, I was there to capture a piece of that pipeline, look at corridor management, so encroachment of the vegetation, and also continuity of the pipeline itself. But while we were there, we actually captured the pump facilities, the substations, and the power lines all in one. So you can see that that value add of being able to capture all the data all around you just is enormous. So here's also another interesting use case. It's one of the dams, and you can see the black space up in the top right-hand corner. That's actually the water that the dam's holding back. And I'd love to give this as an example because sometimes the absence of data is just as informative as the presence. So with that, we can look and see what the water levels are from the same scan that we're using to look at the condition assessment. Here, the colorization is through an intensity value, but we can see that the higher yellow colors are actually where the concrete is deteriorated a little bit. So multiple questions can be asked off the same data set. I think that's really a cool part of what we do. Terrain and understanding what terrain is a really important aspect to a lot of projects. And I like this because it not only shows how we can capture steep cliff faces much better than a traditional technique from a TLS. I mean, you have so many shadows if you're trying to do it from the bottom of the TLS. I think that the colorization with the GoPro is phenomenal on this. I collected this data personally, and it looks just like that in real life. For more than just pretty pictures, we can use these for industrial purposes as well. So in this facility, they're decommissioning the site. So they need to understand where we're going to put this 10 or 20 or 30-ton crane, and so we can lift these heavy components off safely. You can see the terrain makes that very challenging. So they may have to do some earthworks in advance. So it's not just about the structure, it's also about the surrounding environment. This was a fun one. We found out the day before that we might have an opportunity to go to this Maersk drill rig platform that was in shore in Norway. And we were told that we would come on site, but that we would only have 1 hour while we were there. And that's basically because the guys all take lunch together and we would have the facility for an hour. So what you're seeing here is an hour's worth of work where we did a 20-minute flight around with the drone, and then I walked around for 35, 40 minutes, give or take, and covering as much of the structure as I could during that time. Again, the versatility deployment allowed me to go inside of those spaces, and with the walking scans, whilst the flying allowed us to capture aspects of the facility that I would never be able to reach without the drone. Our merging software within the Emesent package brought this all back together. And you can see that perhaps with a little bit more time on site and more access to such a facility, we could make a more complete picture and likely do so within a day. My previous background is actually marine science, so this one is actually true to home for me. This is a combination of Hovermap data, which you see on the surface, plus side scan sonar data. So in a way, without trying to oversimplify it, a point cloud is a point cloud is a point cloud. And in this case, we were able to merge the point cloud derived from the side scan data with the Hovermap, and we were able to get a complete picture from the surface all the way down to the sub-bottom profile of that berth. And did another one where we mounted a Hovermap to the front of this little John boat or tinny. I used the pole just to kind of give my arm a break, just kind of help me out a little bit. Tried to imagine trying to scan or capture data in this type of environment using traditional techniques. It would be virtually impossible to set up a tripod-based scanner in here, or it would be a lot of work. Whereas in this case, a simple mount, push the button, get underneath that low tide, and we drove up and down, and I also walked on the surface. So in this case, Hovermap was deployed on this small boat, and I also walked with it on the surface, and we were able to digitize that entire wharf from the assets that are sitting onto it to the structures that are underneath. And if we had had the side scan on that particular visit, we would have that all the way down as a complete picture. I probably spent, without exaggeration, probably an hour or two on site at most to capture all of this. It's not just ports and marinas that are operational. This is a dry dock. So this is actually a maritime museum in Brisbane, but it just gives an example of how dry dock facilities can also be captured with Hovermap. We also collected the entire, or at least the accessible areas of the inside of that ship. Now, speaking of ships, this is one of my favorites. It was on the USS Midway Museum There was a movie that came out a couple years ago about the Midway, and this aircraft was in the movie. It's a TV dauntless from memory, but they have a display for the movie down at the other end of the hangar deck, and they were wondering if the plane would fit down there, but they didn't want to move this delicate plane without knowing that it would fit. So I walked around it in about, I don't know, 2 minutes, digitized it, put the wings back on digitally because they were laying on the ground, and then I put it back to where they want the museum or the movie display. I basically sent them this data set and I said, I think it'll fit. About a month later, they sent me this photograph and they said, yep, it does. So that was really cool. Forestry is a new, it's a relatively new area for us, but it's really exciting, the new things that they're doing within that space by being able to digitize these experimental plots within larger forest and plantation systems. This shows a quick video about how our autonomy systems can even handle complex environments like a forest. So through this type of capability, we're able to image underneath the canopy. So forestry and LiDAR have had a hand-in-hand relationship for a lot of years, and there's some amazing use cases out there, but it's almost exclusively from an above canopy perspective. And the forest itself kind of filters out a lot of the points, so you don't get the rich ground returns that a lot of times the guys are after. But also what they miss are some of the basal heights and other diameters at certain points of the tree. And there's all these other cool metrics that they're now being able to derive by having greater insights into that space. Now, of course, the drone is a fun way of doing things, but we always say, you fly because you have to, not because you want to, only because it does introduce additional risk. But in this case, you can walk with it in that space. We've had them on backpacks. You can use it on a quad bike and drive around. So it really does allow that. And what you can see here is that it's a combined flight and walking based capture. And what we have here is the entire profile of the tree from canopy crown all the way to the forest floor. Thought I would run through a few case studies, and this is a really simple one, but it's one of those where you realize, wow, some way in its simplicity, it can really change how we think about big and small tasks. So a lot of the data that we show are from big structures. This is just a waste facility, but in order to be Part 306 or 360 solid waste required to meet the requirements in New York State, they have to understand the volumes and how this material is being handled, right? So in 15 minutes, they flew this stockpile and they were in and gone. And that quick capability allows for it to be more cost friendly as far as capturing this data. And it also becomes part of the digital record. So if somebody has an audit later on, they can keep pulling these out and it just becomes part of that digital record. This one's particularly neat. This is from our friends in Sweden called EMFCO, and they were scanning a 1960s hydropower station in Norway. They hadn't had a look at this kind of these spaces within the hydropower facility for quite some time. And so they were getting a new insight as to what the conditions were like. It would be fair to say that nobody involved in the building and construction of the facility was still working there, right? So in this case, they were able to use a combination of walking and flying scans to bring them back together to give a more complete picture of that dam overflow tunnel. And here's another one from our friends at Kimberly Horn and Pete Kelsey, terrain and land development. So this is a small-ish project where they're looking at new construction, new build. There is this creek that's running, so there's water movement flowing through the landscape there. In a 15-minute flight, we were able to capture that data, digitize the environment, remove the vegetation, create the terrain model, and that was used in the planning and the land management part of the construction. And another one from EMFCO, it's a 12th century fortress castle, I guess, as they have over there, which is really cool. 15-minute flying scans, probably some walking scans in there as well. They spent 4 hours on site, so only in 4 hours they were able to capture that data and process right there on site. And the deliverables included 3D models, volume calcs for earthworks, linear and area measurements, and digital terrain model for planners. This kind of stuff is also really interesting for historic preservation and even some new ideas as far as virtual tours and accessibility for people that have maybe limitations that don't let them travel or visit certain sites. Point cloud to BIM, this is garnering a lot of attention at the moment, and it has to do with the speed that we can capture the data with these mobile scanners like Hovermap. This is a 5-story building, and I collected it by myself. I was on site for 4 hours. Probably could have spent a little bit less time, but we did a bit of talking as you do. And obviously I went into pretty much every nook and cranny that the building had to offer. And the idea is to create floor plans and derive insights from a emergency response perspective, like if there was something that happened on site, where that situational awareness, which we'll talk about in a second. So from our team, we were able to take that raw data and put it quickly into Revit and start to derive floor plans and elevations. And here we can see the detailed floor plans, but because we captured the data so richly, you can actually see individual chairs, individual desks. And if you wanted to, one could digitize those assets in space in situ as well. This is a simple bridge. It's nothing terribly exciting, but it proves an important point. Bridges have load limits, and to be able to understand, especially in older bridges where information may be missing, or maybe it's in a different part of the world where those sort of records aren't always kept. Being able to digitize this bridge took about 10 minutes of time on site, and it not only captured the bridge, but also the land and the topography around it. So we could look at the structure as well as potential erosion or accretion issues that might be causing structural issues. And as always, it's not just a pretty picture. We want to be able to derive new information. So from there, again, back into Revit. And here we are with structural information on the thicknesses and widths of beams and other load-bearing structures. Office spaces are no different. So in this case, there was a renovation of a factory office. They wanted an as-built. Hovermap was used to scan for 15 minutes outside and then 15 minutes inside, so half an hour total. We used point cloud and point fuse CAD ready, or point fuse to make a CAD ready model from the point cloud. The benefits here were the rapid low cost model for the client. So we can see here that that's been loaded on the top screen into point fuse, and the floor plan BIM model ready to export into Revit for further analysis is ready to go. And point fuse is an excellent tool for this. It really streamlines the whole thing from just a few clicks you get from that original model to the BIM. It's really amazing. I like the idea of this one because it's so topical these days. So this is a server room that needed expansion. So server rooms being full of computers that are helping us use the internet and do what we do every day. They're expanding, and understanding the installation of the current install and how new componentry, even how cooling and ducting is going to work and fit within those spaces. In this case, we can capture that within a 2-minute walking scan. And that speed and time on site really does save a tremendous amount of money and adds value to the client. Again, export to Revit for working models. So on the left-hand side, we can see the original point cloud, and then the basically scan to BIM, scan to CAD model on the right-hand side. Bridges, as we talked about at the very beginning, are always just of high interest. Here, the California Department of Transportation and PG&E we're interested in this particular bridge, and not just the bridge, but the utilities that are running underneath it. We captured this in a 15-minute flight, and again, accurate, low noise point cloud with CAD outputs. So again, point cloud on the left-hand side and the Revit models on the right-hand side, and even down to the fine details of the trusses and the railings. Here's that elevator shaft that I love. And it's, again, that the same data that we saw earlier in the presentation, but here it's been converted into a 3D model with all its dimensions and all ready to go in that 3D CAD via the Revit software package. And I wanted to spend a little bit of time on some of the work that I've been doing with first responders lately. So here we have a spot again, tackling those rocks with Hovermap on the top. And we used Hovermap on the spot, but also on the drone to capture this data set of this old house that they use for testing. So the exterior was all from Hovermap outside on the flight. And I sent Spot up the stairs and into this building, and all of us stayed outside. So if you were thinking about it from a first responder perspective, they're not having to enter the house without understanding what the situation is the layout, where the entry points are, where are the exit points. Keeping first responders safe when they enter unknown environments is a critical issue. Change detection is a really hot topic as well. We talked about a little bit earlier with the mining and the shaft scan. In this case, this is I think somebody maybe got a little bit out of control in their vehicle. On the left-hand side, you can see that it knocked over a post. You can even see the tire marks just barely in the photograph, but in the Hovermap data, you can see the change in detection. There's the wheel tracks and the knocked over post in the red. This one was just captured completely opportunistically. The guy who lives at this house just scanned his front yard the day before. He woke up the next day, this happened, so he scanned it again. And I thought it was a really cool, but a very simple example. Spot, again, and this is with a GoPro Max 360 camera on the top. This is part of a bomb blast course that I was invited to with the police. And so there's a mannequin there, and we sent Spot in with Hovermap and the GoPro Max to image a before of the event. Just to warn you, there is a blast here. So this is the actual blast. So just to warn you that there will be a blast. And here it is in slow-mo, which is always really cool. And the idea is to send Spot in with Hovermap. And there's many reasons that you could potentially use Spot with Hovermap in this case, but what was of particular interest was the small footprint that Spot has on the ground. So even as this Spot is walking around, he's not really moving or altering any of that shrapnel that you see on the ground. That's all forensic evidence that if human beings are walking around in there, that you're going to be kicking around. So we were quite pleased to see small Spot's small footprints while we were collecting data from both the Hovermap and the GoPro Max, the 360 camera. Here's the Hovermap scan, the before image on the left, so and the after the blast on the right. Both collected by Spot. Different perspective of the bed before and after. Again, Hovermap point cloud collected by Spot. And then again, throwing it through the change detection algorithms, we can see the before, the after, and the change, right? So one thing that you can notice is on the bottom left hand, the bed has completely picked up and moved. The doors on that wardrobe have opened up and moved. And of course, all the little yellow shrapnel bits all over the ground inside the room. So that's where we're pushing boundaries now. Where we've also been pushing boundaries for the last few years is with some really talented people from the CSIRO, and there's other talented teams around the world that were competing in the DARPA Challenge. I think we did really well in that, and especially given the talent that's associated with that kind of project. But a key component of that work is robotic teams. And this is robots working with robots to map and cover areas independently. They're given a task, they're given an objective, and then let loose to explore those spaces. And I think that there's a lot of different applications for this. Obviously defense, but also first responders in emergency situations. So earthquakes or building collapse, you let the robots go in, map, and then bring that information back or send that back real time to the command center before you send first responders in and put more people at risk. So keep an eye on this space. It is not science fiction. It is definitely science future, and the fact that it already exists is just going from these kind of research and development projects to a commercial. That's the phase that we're in now. Really exciting, so please watch that space. Hovermap advantages. I'll finish off with this. It's kind of a summary of what we talked about today. The versatility of the platform. I think that just speaks volumes. It can be used in so many different ways. It's really limited by your imagination and your needs as to how you're going to be able to use this one single platform that I don't know of any other product on the market that does what this does. The rapid deployment and ease of use. It takes about 30 seconds for Hovermap to be ready to go once it's out of the box and the battery's plugged in. Its ease of use means that highly skilled people can be spared from the field collection side of things and back at home office working with data as opposed to collecting it. Mapping previously inaccessible areas or dangerous places, the drone spot, even the bucket loader that we saw earlier in the presentation. High resolution data means fewer shadows. Shadows are missing information. So you can see here on the right, I scanned this working stockpile. This is a production facility. So it's loading a train from material from the mine. And if that stops, then the mine stops, right? So by not putting people at risk in that environment and on the production floor, then we can keep people safe. We can access the stockpile from a different perspective, get more accurate information, fewer shadows. All the while, the trucks are running and the trains are running, and it's not stopping production at all. That improves our safety because we don't have people in that operational space, and we can obtain this data. If we scan that for 5-10 minutes, we would have that information ready for management decisions within a half hour to 45 minutes, which provides new insights and actionable information for them to be able to judge how they're working with this facility and other facilities like this, where those time-critical decisions can have significant cost implications. So none of this would, of course, be possible without the Velodyne VLP16 that's on the front of Hovermap, and we greatly appreciate Velodyne's support over the years and the opportunity to be here with you today at our virtual CES 2022. Thank you very much.